I got it.
Oh, where's? Oh, sick. That's what the story is. Dude, I want to play colors sometimes.
No, I just words. Yeah.
You got time. Hey, so I have a few accounts that I've created for people. Is there a Kyle Bloomster? Yeah. These are accounts in MATLAB that you're going to need in order to program this semester. Madeline Coleman, Jordan Dixon. Oh, there. Jeremy Howell. Ambicora? Am I saying that right? Yes. Andrew Coughlin?
Yeah.
Am I saying that right?
I have to write about
Really? Oh, my program is probably going wrong. How about your user ID? Is it correct?
Yeah.
Tisha Bagara? No? How about Jason Morrison? Sabrina Rodriguez?
Yes. All right.
So if you did not get one of these things, that means you already have an account in the MATLAB. Now, you may have gotten that account several semesters ago and have absolutely no idea what the password is. If that's the case, hang around after class. Remember, this class goes from 1 to 150. Doesn't fill up the entire 1 to 230 time slot. So this class goes from 1 to 150. Hang around after class. We'll go over to the MATLAB and we'll make sure that you get your passwords squared away. So if you do know your MATLAB password already, you're fine. You have a MATLAB account. You know the password. You've used it in stats. You've used it in CalcLab, what have you. You're fine. It's the same account. That said, this account is separate from your Windows account. We use the same user ID but a different password. So be aware of that. You may want to use these instructions here to change the password on your account to something more something easier to remember. Okay, I guess we're actually going now. Welcome to C++. My name is Albert Schuler. I am not a computer scientist. I'm a mathematician. This is Math 167, not Computer Science 167. So I have a tendency to be very mathy in this class. That's a good thing, in my opinion. Computer science usually, in its roots, came from math departments, and in many places still lives within math departments. It's a very logical, mathematical, rigorous discipline, and so there's nothing wrong with a mathematician teaching it. We will meet in this room. We will use this book in addition to a few other things. This is an old edition of problem solving with C++, but since the 8th edition has nothing valuable to add, I'm content with using the 6th edition, and it's a lot cheaper for you guys. Was everyone able to get a copy of this? The bookstore has copies if you couldn't find one online. My office is Olin 240. It's right down the hall on the right. Office hours. I have TBA or by appointment. I've actually now fixed that TBA. Generally speaking, I will hang around after class. So this class goes from 1 to 1:50. I will hang around until I teach again at 2:30. So I'll be available for questions during that time. I will also be having office hours at 2 o'clock on Tuesday and Thursday. I'll write all this in here. This is stuff that I've just decided today. It's always a moving target at this point in the semester. This page is where you can get all of the information about the class. It's caret.whitman.edu. I roll my own web pages and roll my own course materials, so you don't go looking for Clio sites. I don't use Clio to put my stuff online. You've got just broad strokes, philosophy and goals down here, and a description of the homework, etc. Let's talk a little bit about goals. At the end of this class, you should be able to think algorithmically. What does that mean? It means you have something in mind that you want to accomplish using a computer, and you're able to sketch out a process whereby the computer would accomplish that task. It involves being able to take a problem and break it down into component pieces. It involves being able to program those component pieces and then put those pieces together in the correct order to accomplish some sort of computational goal. I also want us to generate really clear, well-commented code. We'll talk much more about all of these later. One goal of mine is that you would not be afraid in later work to pull out C++ and program and do a quick program to accomplish something, say, in physics. Perhaps in physics you've got some data and you want to do a Fourier transform on that data. It'd be great if you could go back to C++ and quickly do that. We'll learn how to debug computer programs in here. It's one of the most difficult parts of programming. Probably the easiest thing to do is to learn the syntax. The hardest thing to do is to make the damn thing do what you want. Understand the role of programming languages and compilers in the development of software, and some historical stuff. These are sort of lumped together. To get at these goals, let me skip. I guess I'll go back a little bit. I have these little presentation questions. So every class period starting next Wednesday, I think, I'll give you more information as we progress. One person will stand up and talk briefly, 5-6 minutes, about one of these questions. Between now and, I don't know, let's say Friday, go to this website, punch your user ID into the empty box, pick one of the questions, and click submit, and that question is yours. And come Friday, when everyone has done this, possibly even earlier, I will take the list of questions and the list of people, and I'll randomize it, and then one a day for the rest of the semester, we'll get somebody to come up and talk about this particular question. You're familiar with this already, Lauren, yes. So if there's a question, if you have some topic about computer science, robotics, technology, what have you, that is not on this list but that you're very interested in or that you have a personal interest in, by all means, send me an email. Don't pick one of these. Send me an email. Say, I'd like to talk about this instead. And as long as it's sort of within the ballpark, that'll be fine. Otherwise, pick one of these questions. I'll talk more about my expectations on how you present these things. Perhaps Friday when I present the schedule. All right. No, I want to go here. Now, the heart of this course is really the programming assignments. They'll essentially be a sequence of assignments, roughly a week long each. You will write a program to accomplish some particular task that I've asked of you. You can read the homework guidelines there. You can work with other people if you like, at most one other person. If you choose to work in a group or in pairs, just submit one copy of your program, and then at the top in a comment, you just let me know who contributed to this code so that I know to give you the same grade, each person the same grade. I also look for something called an above and beyond component, something very small, but something that extends or adds to or is somewhat related to the task at hand, but not something that I asked for explicitly. I have a late policy, which is governed by this formula, d times d plus 1 over 2. Some of you that have had me before know how this works. That is the formula for summing up the first d positive integers, 1 plus 2 plus 3 plus 4, ... plus d. It's due to Gauss, I think, originally. And if you turn your program in 1 day late, you lose 1 point. If you turn it in 2 days late, you lose 1 plus 2 points, which is 3 points. If you turn it in 3 days late, you lose 1 plus 2 plus 3, 6 points, and so on. And I've done the calculation, and if you wait 14 days, don't bother. All right, if you get somewhere between 13 and 14, it goes above 100. So that's that. This has been a successful policy for me in the past. Most people, they have something going on, they have a really busy week, they're willing to take a point or two just to push it off a couple of days. And then I don't have to negotiate with you, right, about, oh, I had this, that, and the other thing, can I turn it in late? Most people will just take the point. I can tell how late or early it is just by the timestamp on the file when you submit it, so I have an easy way of keeping track of that. 2 in-class exams and a final. The grade components are just there. This class is remarkably easy to cheat in. If Srija writes a program and shows somebody else, or she could send a copy to somebody. I know she would never do that, but she could send a copy to somebody. That person can sort of take it and change a few variable names and submit it as their own work. Usually I catch it, so don't do that. Okay? If you're having trouble with programming, come talk to me. That's what I'm here for. If you have something that's going to be really dramatically late, or you're having a nightmare of a week, talk to me. Okay? Don't copy a program from somebody else or from the internet. One time a kid turned in a program. I think it was for a hangman game that I had assigned. And I'm looking at this thing, and it's using all these techniques that I had never taught in class. And I'm thinking, wow, this is really sophisticated. So then I go to Google and I type in hangman C++, and it was the first program that came up on Google that he had submitted to me. So just don't. All right. I emphasize this much more in this class than in other classes. It's been much more of a problem in this class than it has in any other class that I've taught. I would just don't do it. Okay. Your assignments will constantly be updated and posted here. For example, today's Monday, January 14th, and I'm asking you to read Chapter 1. While you're reading Chapter 1, I want you to pay close attention to what are called the self-test exercises. They're not at the beginning or ends of sections. They're just kind of sprinkled throughout the text. So please do work through those and understand those, because I'll actually draw from some of those ideas as when I give you an in-class exam. It's very difficult to test you in class on writing programs, but it's fairly easy to test you on concepts and syntax and things like that. And that's what these self-test exercises do. You'll also see a link to the first homework here. Oh, and by the way, the self-test exercises are for you. You don't need to write them up and turn them in. They're just something that I want you to pay close attention to. The things that you're going to write up and turn in are here. This is your first homework, and it's due Friday, so get on it. So the first thing is to fill out this Ma167 information form, which just gets some background information for me In particular, this field, even though I didn't make it required, this is a useful field. If I need to get in touch with you, it's really hard sometimes to get a phone number. So if you can give me that phone number, that'd be great. You don't have to, though. Describe your previous experience with computers. Again, there's no prerequisite for this class. I'm mostly just curious. And so on. So that'll be due. You're going to learn how to log into the MATHLAB. I'll talk about that today. You're going to learn some basic Unix commands. Talk about that today. We'll talk about the Vim editor. And then 5 really is, I think, the only other thing that you have to submit. Problem 5 is submit a Hello World program. This is usually the simplest of all possible programs. Every language has its own little Hello World program, and you're going to do C++'s version of Hello World. The purpose of Hello World, obviously, is not to print the words Hello World to the screen or what have you. The purpose is to make sure that you know how to use the technology so that you can write programs and submit them. All right, so there's the first homework. I will return to this, and we'll talk about that some more in a bit. Any questions so far? Go ahead.
Yeah, if we have sporting events or something, and homeworks or exams, or do you want us to just
exams I can negotiate with. Homework is still due on the day, and it's an electronic submission system, so you can do it from anywhere. Yep. Go ahead.
What sort of compiler are we going to use to write code?
We're going to use a C++ compiler called GNU-CC.
And do we have to use GNU-CC? Yeah, said Xcode or something.
You know, we're getting Xcode is fine. I'm gonna show you a technique that will work for everybody in the room, and then if you can set something up on your own computer that will duplicate what I'm looking for, have at it. Okay. And as we go through the semester, I will. It's really important at this point not to overload people with a whole bunch of technology and stuff, not to just pile it all on. So what I want you to do, everybody, including people with Macs and Xcode and all that sort of stuff, is to just work with me on this, follow through, do what I'm doing, so that we all start from a common technological foundation. And then after we're all comfortable, maybe after a week or two, and we're using the technology, we can start branching out a little bit. And maybe you can start programming on your own computers. All right. Other questions? Okay, I think we're ready to start doing computer science here. Computers, they're all around us now, only more so. And 99.9% of the time they tell us what to do. This class, we're going to tell them what to do. When you're looking at, for example, I've got my laptop open here and I'm talking to you, and you've got phones in your pockets, and you look at them and there's all these pretty pictures and so forth on the screen. At the heart of all these computers, there is some sort of file system and files. And essentially these files contain instructions that are executed on the processor, on the hardware, to do what we see here. To that end, we are going to be working, at least for the first several weeks of the class, we are going to be working at a very low level. We're going to be working in a file system, editing files of text, of characters, of typewriter characters, no GUIs, GUI, graphical user interface, no pretty pictures, no buttons, just a command line and a screen filled with typewriter characters. And then we'll move on from there, but that's going to be the common foundation. In order to do this, I have given you, or you already have, accounts in the MATHLAB. I'm using Windows here. How many Mac people? Raise your hand. Okay, and how many Windows people? So about 50-50, maybe even a little more Mac. For Mac people, you're not going to be seeing the stuff that I'm presenting here on the board. Let me show you. Let me start talking to the Windows people, and then I'll have these little asides for the Mac people. That said, if you forget anything that's said in the class, I'm currently recording this desktop, and it has what's going on the screen, and it's recording my voice. I'll put that on YouTube sometime before midnight tonight, and all of the things that I do in class with respect to technology on the screen, you'll be able to review on the YouTube video. So if you forget how to do something, you can go there. Let's talk about Windows and how we access the MATHLAB from Windows. There is a program out on the internet that's free. Come on, Google. There you are. Called Putty. If you type Putty into the Google search box, the first thing that comes up is this program. Go to that first link, the Putty download page. And remember, this is for Windows people. For Mac people, it's actually a little bit easier. Grab this first guy, putty.exe. Oh, come on. Putty.exe. You can right-click on it, and you can save link as. And you can put it in downloads, which is probably where it wants to end up. I would just put it on the desktop for now. It's called Putty. Click Save. And unlike a lot of the things that you download from the internet, this thing is ready to go. It doesn't have to be installed, unzipped, anything like that. It's now ready. So there it is. I click on it. Mine's pre-configured to have a couple of common destinations, but just ignore that. Up here, use your account in the MATHLAB. So type math.whitman.edu. This is a computer that is actually in my office, but it is important to the MATHLAB. Okay, and it's asking for a login. This is your Whitman user ID. In my case, I can't see. Oh, there we go. Shula. Sometimes if it's the first time you've logged into the MATHLAB, you'll get a little window that pops up and says, there's a different SSH key. Do you want to accept it? Just say yes. And then it only happens once, and you move on. Here you type your password. Now this is not your Whitman regular network password. This is your MATHLAB specific password. For those of you that got new account information today, it's that password. For the rest of you, you have to know what your password is. And you'll notice nothing happens when I type that password, but it's there. Okay. This is how Windows people will get to the MATHLAB. Mac people, I think it's on my home page. Possibly not. For Mac people, there's a thing called Terminal. Okay? And it is exactly the same as this thing that I just downloaded and put on my desktop. And it is in Applications Utilities. So I'm saying this, write it down. It's in Applications Utilities. It's called Terminal. You run Terminal, and then you'll have something that looks like this. Only problem is this little prompt right here in this window is in the MATHLAB, and the little prompt in your window is going to be on your local computer. How do you fix that problem? Well, let's pretend that I'm on a Mac and I've just run my terminal program, and I'm sitting here on my local computer. I need to be on the math department computer, so I type this. SSH math.whitman.edu. And I hit enter, and it's going to ask for a password. And now I'm in the MATLAB. So for Mac people, it's a little different, but not terrible. So you Mac people have to know this. You'll run your terminal, and then you'll use that. All right, so I'm now logged into Math twice. I'm going to get out of that. So here I am at this prompt. What is this thing? Well, I just mentioned that everything on a computer is based on files and folders. So you have your computer. Let me draw a computer here. And maybe a keyboard here. Okay. And somewhere in here is a disk drive. Some people call it the hard drive. And on the hard drive are files and folders. That's pretty much all that's there. There are some other oddities in there, but mostly files and folders. Files and folders. Imagine that you have a filing cabinet in your office, in your dorm room, what have you, and you jump into it. Okay? And it's filled with papers, and the papers are all sitting in manila folders. Okay? You jump in there, you're going to land in one of those manila folders. And this is a weird kind of file cabinet because some of the manila folders actually have manila folders inside them. So you jump into the filing cabinet and you land inside one of the manila folders, and you look around. What's around you in this manila folder? Folders and files, right? Folders and files. Files are just pieces of paper, documents, what have you, that have been tucked into the manila folder. And folders are, of course, other manila folders that have been shoved into this existing manila folder. So when I log in to when I logged into this thing over here, I jumped into a filing cabinet and I landed in a folder. If I want to see what's in this folder, I use a Unix command type called list, and it's shorthand ls. I type the letter L, the letter S, and I hit the enter key. And there's a bunch of junk in there. So I'm sitting in this manila folder, and I look around and I see 1, 2, 3, 4, 5 other manila folders. Those are the guys in blue. And I see several files around me. And that's it. Everything is files and folders. So ls is a really important command to know. In fact, I'm going to get out of this and get a more visible version of this program that I've prepared. Actually, let me go to the MATHLAB, not to my office. Okay, so as soon as I type enter here, I jump into the filing cabinet. Now I'm in a file. I type ls to see what's around me. And that's what I see. I see one interesting looking folder, Spring 2013 167. In fact, it's so interesting I'm going to get rid of it. See how it's gone now? I use the rm command to get rid of that thing. And don't ever do this. rm-rf is like using a nuclear weapon. You really have to know what you're doing in order to use that. RM stands for remove, -rf. R means recursively remove, which means it's going to remove that file and anything that it holds, any files and folders that it holds. And F means forcefully, which means it's not going to ask you any questions. It's just going to do it. Okay, so that's just a point of reference. So I see around me these files and folders. For example, the desktop how do I get into one of these folders? So say I'm sitting in this manila envelope and I see this desktop folder over here and I want to jump into that one. I use the change directory command, cd desktop. And there's a space here, and this is a case-sensitive file system. So capital D means something different than lowercase d. I hit enter, and now I see the prompt changes, and it's actually showing me that I am sitting inside this folder. It's really kind of useful. And if I want to see what's around me in this folder, what do I do? ls. And there's nothing on my desktop currently in the MATLAB. Well, there's nothing in here. I want to go back to where I came from. After you log into this thing, you land in the default folder. If you ever want to go back to the default folder, just type cd with no arguments, and you'll go back to the default folder. And if I want to see what's around me, I type ls. So I'm back where I came from. So does everybody see when I jumped into desktop and I looked around, there was nothing there. And when I went back to my default folder, I look around and I see the same thing I saw at the beginning. Go ahead.
What do you type if you just want to go back to the one you were just in?
There's a couple of different ways to do this. So I can, the way that I think about this in my mind is I think about going down. So I'm going to go down into desktop. And the question is, what if I just want to go up one? Let me make another, well, let me go into my Dropbox directory instead. So I'm going to go into Dropbox, and I see lots of folders and files. I can go into classes, and now I'm 2 folders down from where I started, right? What if I want to not go all the way back to where I started, which would just be cd, but I want to go back to this guy? There's a special symbol for that. cd space double dot. cd 2 periods. And this will move you up a directory. Doesn't like that. Oh well. If I wasn't doing fancy things with my push D, it would. Okay, so that moves me up, and in fact I can do that again to go up. So there's the cd command, which stands for change directory. Go ahead.
How did you know to put the slash after classes? Or did it automatically?
It automatically did that. So you may notice that as I type, every once in a while the thing seems to type itself. That's me using the file/command-line completion key, which is tab. So if I don't feel like typing the whole thing, if I type enough of it to uniquely identify it and I hit tab, it'll finish typing it for me. This command line, what we're using here is Unix. This Unix command line has been around since 1970. And it is an amazingly efficient place to work if you know the tricks. And that's the big if. And my hope is over the next 2-3 weeks, with a little diligence on your part, you'll start to pick up some of these tricks, and this command line will be far less onerous to use. Okay, so that's the change directory command. Let's pretend that we want to do our first homework assignment. So I log in and I'm sitting at the default folder. You want to be organized in this class. You're going to be generating lots of files that you're going to be submitting to me for grading, that you're going to be playing with for examples and so forth. I suggest creating a directory, mkdir. What do you think that stands for? Make directory. Yeah, you know, it sounds great. Make directory, oh yeah, that makes sense. But how do you know that? Yeah, exactly. I'm going to show you the 5 or 6 commands that you really, really need in Unix, and then maybe we'll add some as we go along. So make directory, make it meaningful, like spring 2013 Ma167. Because maybe you have other spring 2013 classes that you would like to put in here. Unlikely, but there you have it. So if I do that and I look around ls, I see that that folder is now back. How do I get into that folder? cd. And that's an awfully long file name, so I just type the capital S, and there's only one thing in the whole folder that starts with capital S. I hit tab and it finishes typing it for me. I hit enter. I look around. There's nothing there. Maybe I want to put homework 1. In fact, I want to put everything in here, but let's say I want to do homework 1. Probably should put that in its own folder. Go ahead.
When you make something in the directory, does it always just say hello? Where was that?
Where did it say?
It's hello.cpp.
No, that was already there. That's just me prepping for class.
Oh, that's nice.
It's not in that folder. If I look around in this folder, you see there's nothing in there. Now, look ahead a little bit. This semester is going to have homework 1, homework 2, homework 7. Probably want to keep all the files associated with homework 1 in one folder, all those associated with homework 2 in another folder. So let's think a little bit in advance and make another folder, H01. Why not just H1?
Because when you're gonna if you are use tab and say you have H100,000, start with the whole one.
Yeah, and we're not going to have 100,000 homework assignments in here, but we might have 11 or 10. And so it does two things. It's sort of, I anticipate that we're going to have double-digit number of homeworks. And so I use a leading 0 here because when I do that and I type ls, homework 10 is going to be listed after homework 1. But if I make this guy and I type ls, that still works, but anyway. If I make this guy, homework 2 comes after homework 10. So this is just me knowing a lot about my file system and how it works. I know enough that homework 01 is going to be much cleaner and neater than homework just 1. So I've made a lot of directories that I don't need. What do you think that stands for? And I've gotten rid of them. So I'd like to put my stuff for homework 1 in homework 1, in H01. And I look around, and there's nothing in there now. So this is all just created from the default directory here. I created this guy, then I created H01. You can call these things whatever you want. These are just suggestions. Okay, let's try writing a program. Yeah, we've got 15 minutes left. Okay, so there's nothing in here right now. Here's the next kind of big, there are 3 big steps today. The first one is being able to log into the MATHLAB using either PuTTY or the Mac terminal. The next thing is to know how to navigate this command line using Unix commands, ls, cd, make directory. Okay, the next big one, and this is going to be a real biggie, is the text editor. All right, I am going to edit a program. I'm going to create a new file in this folder, and it's going to be called hello.cpp. Bear with me here while I do this, and I'll explain. So I'm going to put some gobbledygook in here that makes sense to the C compiler. Okay, so before there was nothing in there. And then I ran my text editor. It's called a text editor because all this thing knows how to do is put keyboard characters into a file. It is far less sophisticated than something like Microsoft Word. With a caveat. So Microsoft Word, for example, can take words and make them boldface, or can italicize them, or change the font to something crazy, or make it really big. Vim can't do any of that. All Vim can do is put typewriter characters into a file. So I did this Vim hello.cpp. It didn't exist, so Vim created it for me. And then I typed all that stuff in there, and now inside that file are these typewriter characters. And these typewriter characters are actually understood by the C compiler. So the next step is to compile this thing. So our C compiler is a program called G++. Just like ls and cd are also programs that run on the command line, G++ is just yet another program that runs on the command line. And what does it do? It takes these typewriter characters and converts them into something that this computer understands, or in fact, the MATLAB computer understands, and can execute. So I do that, nothing happens. It goes away for a while and then it comes back. But if I type ls, what do you notice? There's a new file in town, it's called a.out. And these guys, this file contains the instructions for the computer. And I can run that thing with this little incantation. So I've just done your first homework for you, except for the above and beyond. Why do we have to go through this? Why can't we just make a.out and be done? Yes?
Oh, that was answering your question. So if we make this for our first assignment, we just submit the hello.cpp.
Yes. And I'll tell you how to do that, hopefully by the end of the class too. We're not going to get through all of this stuff. Remember, this isn't due till Friday. I planned that. We're going to continue to talk about this on Wednesday, and I assure you that you will be able to get through this and get me something by midnight Friday, which is the deadline. Okay. So I opened up that program with my text editor. I wrote the instructions for printing hello world to the screen. I saved it. Then I converted it to something that the computer understands, and then I fed it to the computer. Why do we have to go through this? Because this thing is not for human consumption. This is for computer consumption. And in fact, I can open that thing with Vim. And in here are somewhere the instructions for printing hello world to the screen. But this is something that the computer understands and I don't. So the compiler is doing what, essentially? How do you view the compiler? G++. What do you think's happening there?
Translating?
It's translating. Yeah, it's taking this stuff that I can read, at least somewhat, into the stuff that I can't read, but the computer can. So I speak this one language, C++, and the computer speaks this other language, and the compiler is the thing that translates.
So any type of programming language is just converting it to the computer's...
Exactly. And there are differences. For example, I can take this little a.out and put it on a Mac, and it won't work. So the hardware is what matters. So this compiler that I'm using is designed to create instructions for the hardware that is math.whitman.edu. If you were to compile this on your Macintosh using Xcode, it would create instructions specifically for your Macintosh. And that thing wouldn't work on this other thing. Okay, so it very much depends on the particular hardware that you're using. Okay, let's talk a little bit about Vim. Oh no, sorry. Before I talk about Vim, I want to go through the whole process. So now I've written my program and I'm ready to submit it. I should be a little bit more careful here. Let me put my name up here. and maybe homework 1, hello world. And maybe there's somebody else helping me out with it, and so I can put their name up there as well. Okay, so now I'm ready to submit it. Again, we're starting out this semester, at least for the first several weeks, working entirely in this file system from the command line. And believe it or not, there is actually a command line web browser called Lynx. And what I'm going to do is I'm going to go visit this page that lets me upload files. So use this form to upload your homework files. Program or other file to upload. Do you remember what it was called? What was the file called? hello.cpp. And remember, it's case sensitive, no spaces. It's got to be exactly the way it appears in the file system. My user ID is Shulaw. This file is associated with homework 1. As we go through the semester, that list will get longer. And always the default selection will be the most recent homework, homework 2, homework 3, what have you. But if you're turning in something late, you might want to back that up a little bit. And let's say you're turning in homework 5 and homework 6 is already up there. You would want to check the homework 5 button and then submit it. Yes?
Lynx and what else? Could you go back to that?
Yeah, I'll go back in a minute. Okay, so I give the file name to upload and my user ID. And then I go down, I hit tab till submit is highlighted, and I hit enter. And if you're successful, you'll see a message like that. And in fact, it even tells you what file you uploaded. That's just confirmation to let you know that you're doing the right thing. And then to quit this thing, you see some brief instructions down here. One of the instructions is how to quit. Hit Q. Are you sure you want to quit? Yes. And now you're back. And this is the link. And don't worry, this link is on the class web page as well, but it's certainly worth writing down. And again, you can always go back and look at the video if you forget any of this stuff. It should be you should be able to find it in the video. Let me show you what that looks like on a real web page or in a real web browser. So that's the exact same web page. You notice the URL up there? carrot.whitman.edu 167 upload.html. It's exactly the same, except over here, Lynx doesn't have this nice, beautiful web browser to display it in. It just has to display it in typewriter characters. And so it does the best that it can with typewriter characters.
Where do we submit our above and beyond?
Your above and beyond can be either part of the existing homework, or if it doesn't sort of fit well with the existing homework file, like hello.cpp, just create a second file and put your above and beyond in that, and then upload it associated with homework 1. And the only the important thing to note is you should give it a different file name. In fact, let me show you that. So right now I've got hello.cpp in there. Let me introduce you to another Unix command. Suppose I want to do some above and beyond on hello.cpp. I'll copy this guy to something, you know, hello AB. So there's hello above and beyond. And if I do that, I see an additional file has appeared called hello AB. And what do you suspect is in that file? Yeah, it's exactly the same as the original hello. Now I can edit that guy and do my above and beyond. And now I can compile that. And I see nothing changed here. What happened?
Well, now isn't your a.out hello?
Yeah, the a.out was overwritten. So the instructions in this guy have been overwritten by the new instructions. And if I run this guy, feed it to the computer, I see the modified program is now in place. What if I want to get the other one back? I just have to compile the other one. Now there are ways of creating output so that it doesn't always land on a.out, but that's not important right now. Okay, now suppose I want to submit my above and beyond. Here's another handy trick. If I use the up arrow keys, I can see all of the things that I've typed. Save some typing. Hit enter. I want to upload hello.cpp to my same user ID. And now if I go and look at the homework submission directory, I'll see 2 files there associated with my user ID for homework 1. That's not important to you, but that's how I keep track of things. All right, any questions about that?
I have a question.
Yeah, go ahead, Srija.
So if you were to switch the program without saving any changes you made, is there
To quit the editor?
like you made changes to hello, but you didn't want to save those changes?
Sure. I haven't talked at all about how to use Vim yet. Vim is going to be one of the strangest things, I suspect one of the strangest things you'll have encountered in your technological lives. Vim is kind of like Microsoft Word in that it lets you edit documents. But Microsoft Word, you pretty much sort of move the cursor around with the arrow keys, or you point to a place where you want to type and with the mouse, and then you start typing. This guy, if I just start typing my name, no, my name's not a good example. If I just start typing stuff, unpredictable things are going to happen. Right? And that's because VI, written and used by programmers, it was originally written by a fellow named Bill Joy, who I think was the founder of Sun Microsystems. This is, again, this is the pinnacle of 30, 40 years of development for text editors. And it's extremely efficient. The problem is it's also extremely difficult to learn how to use. VI, just really briefly, it starts out in a mode where you can't type characters. And if you want to type a character, you have to move the cursor to a location, say right here, and open a line. So you type the letter O, which you didn't see me do. You type the letter O, and it opens a line. And then you see down here it changes to insert. And I can type some stuff. Still in insert mode. Now say I don't like this guy. So I get out of insert mode. Now I'm in command mode. And I want to delete this line. I hit D twice. And it gets rid of it. This program, it's called a mode line editor or a modal editor. It has 2 primary modes, a command mode and an insert mode. Okay, it's in command mode right now. If I type I, it's in insert mode and it's ready to take characters. If I hit escape, I'm in command mode again and it's ready to take commands. All right, the whole thing is designed to keep your fingers on the keyboard. No mouse necessary. If I want to highlight some text, I can type V and then I can start highlighting text. And if I want to get rid of that stuff, I can type X and get rid of it. If I want to undo something, I can type U and put it back. Okay, there are no instructions on the screen showing you how to do this. That's why this is such a nightmare. So you'll notice, and I'm almost done. I realize I'm 2 minutes over. Let me just quickly point you for some of the more ambitious among you, because I promised to come back to this on Wednesday. Point you to the homework. And you'll notice here to review the Vim editor tutorial. And here's a fun little interactive tutorial that will get you started. I encourage you to jump on this as quickly as you can. VI, if you really put some effort into it, or Vim will become second nature to you. And I think if you work at it for a couple of weeks, you're going to find that you like it. It's extremely efficient, and it's an editor that's available for every computing platform I've ever seen. There's even an Android version, although it's really hard to use. Okay. Go do what you can with what I've told you. Those of you that need your password reset in the MATLAB, hang out, and I'll be here until 2:30 when I have to teach my next class if you have questions. Yeah, what's up, Rach?
So I